Alright, welcome back to another learning bite from Nitish Sharma Global Tech, and I'm your host and trainer today, Kuldeep, for CCI EI. One of the topic we are covering today, and actually not starting, but last video if you have seen already, that's great. Otherwise, if you have not, you can see it here or here somewhere, I believe. And I'm continuing. So last time we started from SDN general introduction, and now we are continuing it with, so if you remember, I have talked about a little bit about the SD-WAN, a little bit about SDA, and a little bit about the ACI. So ACI I'm not going to talk about because that's not part of my CCI EI actually, and I'm kind of bound in that for now. So I'm leaving that. Right, so I'll be focusing more on SD-WAN in this section of the video, and in the upcoming video I'll be talking about SDA more. So let's say we have this SD-WAN Cisco solution for the automation of your WAN. All right, so why we adopt SD-WAN, or why you should go for the solution, especially out there, or what are the challenges in the WAN that SD-WAN has solved for us in such a way that it has become like the number one choice out there for all the large scale deployments. So why it is so popular, right? So first of all, if I'll simply say that if you'll talk about or compare it with the traditional WAN solutions, say MPLS, all right, you have one 10 Mbps, 20 Mbps MPLS circuit, and your user base increases, your number of application you are deploying in your data center, that increases, and as your users are trying to get from your, let's say, sites to the data center, and your WAN circuit is getting consumed more and more. All right, that is a static part. You talk to your provider and they ask you to wait for this certain amount of time, and your business get hampered, you lose money in that way. So that is kind of take times deploying and implementing the newer strength of the circuit. That is one thing. All right, so when I'm saying this is the time is equal to cost, first factor. Second, when you are doing it, your transport is like, okay, sorry, not transport, your WAN is actually the transport dependent. All right, you have MPLS, you want to have another backup if MPLS link is down, the device is down, or port is down, whatever case is there, you want your certain important traffic to be shifted to another link. So that is kind of working in a active and standby mode. Even if you use some PBR or something, still there is not that much of flexibility or freedom that your users have in shifting the traffic from one link to another. So you are always bound to your transport links. Your WAN is always the transport dependent, whatever that kind of link or circuits you use for your WAN. So that is transport dependency, the second factor. All right, the third factor I want to mention from here itself is a feature called direct internet access provided by SD-WAN. Now what is that? Suppose you have some of the users sitting at one site. All right, so let's say this is your site 1 here, and there are some users. This is another site, and there are some users. There can be n number of sites. This is your data center somewhere, and this is your WAN. All right, and then there is this internet. All right, I'm saying WAN as a different entity here and internet as a different entity here. Why? I'll explain in a moment. So your users here, for example, they first need to go to via MPLS to your DC, and then from the firewall, configured there to make your user connections and your traffic secure, you are following this path to go to the internet. I hope it's clear to you. One thing. Now, if you are using some application like Office 365, the popular example. So what will happen if this path is taken to go to internet, that it brings the latency. What would be better that if my user simply can go from here to here and internet directly, and also the data and connection both are secure. My traffic of like data plane and both my control plane, they are both secure. So you are achieving the best of the both world. Your normal WAN solutions, the traditional or existing, the legacy ones, they don't provide that. All right. So there is this feature. So if I write in a proper way about SD-WAN, this will be transport independency, right? So SD-WAN provide you that, and SD-WAN provide you a great feature like DIA. What else it provides me? So it brings me to the next point where it says, okay, if you are having multiple WAN links, let's say WAN 1, so MPLS, WAN 2, internet, okay, whatever example you want to say, so simply internet. So I can, keep it out of picture for now. But yes, what I want to say that if you have different application and you are using different transport to reach there. So now if I just cut it out from here just for your reference, I know I cannot exactly do it here, but yes, if you see now that this is your DC and you have some application here working, and now see what the point I want to make. If you are using a traditional solution and you have multiple WAN options out there and they are working in active standby mode, so only if one, your primary, or let's say you are using this, okay, not this one, MPLS, your primary path is MPLS, this is your secondary. It means what? Only when the MPLS circuit will be down, you will take this internet path to go to your application. What if MPLS by any whatsoever reason is not giving me the desired behavior or desired quality? What do I mean by that? I need to access a kind of application that need, like if there is a certain delay in that, it will be timing out. Or if there is a packet loss, let's say for that application, I don't want the packet loss more than 1%. This is my threshold I want to define. This is packet loss, my delay, I don't want it to be, let's say, more than 100 millisecond. My jitter, I don't want. So you can see based on these threshold, all right, these values, I want my traffic to shift from one link to another if the quality of the existing WAN link degrades. I'm not saying that link is down. No, those days are gone, right? My link is working, but the quality is down. So my SD-WAN keeps on monitoring all my links and their quality for a certain amount of time, and if the quality degrades up to that, they will shift to another better performing link. So that particular technology is known as application aware routing. Alright, so these are some of the benefits: transport independence, DIA, AAR. I hope I had tried to make it as much clear by these restrictive example I can only show on the whiteboard, but once you'll be out there with me, maybe in some technology class, we'll be doing it on the live rack, labs and devices, and there I'll show you how to configure them and how to, how this beautiful technology, set of technology, they actually work, right? So you'll be amazed and you'll love it and you'll want to be a part of it, believe me. All right, what else I can say? The time factor is there, transport independency is there, direct internet access is there, application aware routing. All right, what else I can talk about? So this is only SD-WAN I'm restricting myself up to, and cost obviously. So you can say that for adaptation, that initial comfort zone barrier for learning, and not just for learning, okay, believe me, even for the management out there, initially when they were adopting it around 2020, so it was a question mark, but later on when people have deployed it more and more from mid to large scale environment, when they have seen the results, when they have picked up those sweet fruits, and now everybody is crazy about them. I'm just kind of thinking at the back of my end while I'm having this discussion that what more I can cover. But anyway, all right, if I'll say that SD-WAN is providing me these benefits, now who are the enablers of this technology for me as a network engineer? So if I come to that, so I'll say SD-WAN make use of some controllers. So somewhere here, let me write SD-WAN controllers, all right. So I always tend to take more white space, so that's why I need to restrict myself here, so pardon me. But okay, if I talk about the controllers here, so one or the first controller is vManage, all right. The second controller enabling SD-WAN technology is vSmart, and the third one is my vBond. If I just give you one high level overview of this, how I can give you that? So let me use this bright one here and say that somewhere in my data center I have my controllers, okay? vManage, vSmart, vBond, all right? And then somehow by this IP reachability, that I cannot explain that, otherwise it would take an hour or so. But what I'm saying right now that let me say 2 just to explain that, okay? So this will be somewhere, let's say an edge device here, and these are my 2 transport. Let's say this is MPLS 1, and I'm saying 2, but it is not restrictive to 2. You can have 3, 4 or whatever you want to have. And by the way, because today the internet reachability is not a problem for us, it is abundant. The data and the availability, even at the home office, or just if you are a normal internet user, you know that internet is available 24/7 in most part of the world. So remember, that is the first enabler of SD-WAN. We could have these technologies a way back 10 years or 1 or 2 decades ago, but internet was not that much available and stable, reachable to everybody. That's why these technologies were not there at that time, but now it is there, so these technologies are there as well. Coming back, let's say if this is my site 1, then this is my site 2, and there can be as number of sites, hundreds and thousands of sites, and for them actually it is beneficial, the cost factor. Otherwise, if you are just normal user or some sites, you can use the existing traditional solution as well. You don't want to invest in this heavy solution. But yes, coming here and here, this is it. So what is this site? When I say, so there are some edge routers. So in SD-WAN terminology, they are called cEdge or vEdge. Cisco is pushing cEdge. Cisco Edge is more and more, not the Viptela edges. Viptela is a company actually Cisco bought some years before, and then they rebranded this product as SD-WAN, Cisco SD-WAN. So that's why the name is there, but you'll find most of the cEdge is used. But okay, leaving that, my point was how, let's say if I have, there is a concept of VPN in SD-WAN, by the way, VPN, VRF and all. If I have a department here, let's say HR or training, for them I'm defining a subnet, and you want to have one department same here, and they have the subnet here as well. So this is .5, .6, and them you want to talk to each other. Maybe there is another subnet or another department which is 10.2.2.0. Now, traditionally these routers were directly connected with each other, routing protocols were there, and they talk to each other, right? Control plane was enabled on each device, the data plane was enabled on each device. But now the control plane is given to my vSmart. So what will happen? Okay, they will give these routes to the vSmart. There is overlay protocol, OMP. Always remember that there is some underlay and overlay concept will always be there in case when you are talking about SDN. So in maybe future one of the lectures, I'll explain about what overlays, what underlays, what fabric is. Alright, so this actually is my SD-WAN fabric, where my underlays all these reachability options, overlay is OMP, the proprietary protocol, and then this is given to vSmart, and then vSmart give those routes here. So this is the function. So my control plane is my vSmart control plane. vManage, to configure everything from the GUI, I need to have one central pane of control. I don't need to go to my every vManage, their SSH or their, let's say, console. No, I'm sitting in my data center taking access of this vManage from one out of bound IP, and on my laptop I have a GUI, one good beautiful screen, and I can manage all of this. That's the function. So this is my, what you can say, management plane. And this is WAN, it need to be secure, so there should be some authentication kind of initially before these devices can be onboarded and talk to vManage for further configuration and management. That's where the vBond. So this is my orchestration plane or authentication plane. There is a lot, believe me. I can keep going on for hours and hours on this, but just giving you this idea about, so it brings me to another point as well. Point number 5th, security as well. If in traditional networks or solution, if you want to bring security, then you need to configure by yourself all these IPSec. Even the quality of service you want to configure, it was all manual, all right. But in SD-WAN, security is the part of the solution itself. When you will go to vManage, configure the SD-WAN specific things, your vSmart is actually working as the control plane and the security plane. I don't know if that is some word or not, just to make you understand that the security, the key exchange part for IPsec tunnel configuration. Actually, if I can go on, these devices, they make secure data plane tunnels known as BFD or IPsec tunnel, that is automatically created. If you want to exchange routes, and for that this tunnel should also be secure, that is my control plane DTS tunnel. It is also there, configured by default. You don't need to worry about anything. You don't need to configure anything. It is there. That is one of the greatest benefit, that it relieves like a huge amount of burden from the network engineers and from configuration and understanding and deploying perspective. I hope I have talked enough about SD-WAN solution, how it helps us, and yeah, that's it for this video section, I believe, and I'll see you in the next one. Thank you so much.